Hello everybody, welcome back to another problem. This problem is from the Geometry Through Competitions book from mymathcounts.com. Check out the description below and you'll see the link to it. So let's get started on today's problem. So we have that three small circles are congruent and they each have a radius of 8. And we want to find the radius of the large circle. So let's start connecting some points. Alright, so we just formed a triangle by connecting the center points of all of the circles. Now what we can do here is label the length of the triangle. Let's call this point as A, let's call this as B, let's call this as C. And we know that the radius of each of the smaller circles are 8, so you have 8, 8, 8, 8, 8, 8. Now let's create another line. Now let's label this point as here as D. So we know that AD is the height of the triangle. It's the altitude of the triangle. We notice that triangle ABC is equilateral. It's also the median of a triangle too because it bisects the other side in half like we just did here, and it's 90 degrees. Now we solve for AD using the Pythagorean theorem. So we know that AD squared plus DB squared equals AB squared. Now let's substitute the values we already know. We know that DB is 8, so it's 8 squared equals, and AB is 16 because we have 8 plus 8, so we have 16 squared. So we have AD squared plus 64 equals 256. We have AD squared equals root 192. 192, and we know that AD is a square root of 192, and we can solve that even further and getting our answer that AD is 8 root 3, but well, what do we know about medians? Let's connect some more points together. And let's get rid of everything here. So I'm going to make a simple diagram of this to the side of the circle so it'll look much easier. Okay, so just assume that this triangle over here is an equilateral triangle. So now let's create medians. We're creating the medians of the triangle. So we can all see that the medians all intersect at a certain point, and that point is called, this point is called a centroid. And what do we know about centroid? Well, let's label some points. Let's call this A, B, and C. And if we have a centroid, and B is the point of the centroid, we have that AB is equal to 2/3 of the length of AC. So how can we apply this knowledge over here in the circle to the left? Well, let's see. So if we apply this knowledge to the circle to the left, we have that we know that AD was equal to 8 root 3. And let's label another point. Just so I can make this visible, I'm just going to put it. Assume that this red dot is point E, because if I write E it'll look a bit messy. So we also know that E is the center of the circle. So let's find the length of AE. So we know that the length of AE is 2/3 of AD, so AE equals 2/3 of 8√3, so we have it's equal to 16√3 divided by 3. Now that we have AE, let's extend the radius of circle A over here, and well, right here we have 8, and let's call this F. And now we can all agree that FE is the radius of the large circle, because it's from a point on the circle to the center point of the circle. So FE equals AE plus 8, which was the radius of the small circle, and we just solved what AE is, which is 16√3 over 3 plus 8. So therefore the radius of the large circle is 16√3 over 3 plus 8. Thanks for your time.